Hello ladies and gentlemen, this video is for Notes 2-1. This is Unit 2, Notes 1. This unit is all about taking a look at solving equations versus inequalities. I want to start by taking a look at some information very quickly. If you look on the left of the bold line and you look on the right of this line, this bold line, you'll notice that the 3x, the 2x, the 6, and the 71 are all the same. What's different is that this is an equal sign and this is an inequality. Now for those of you that have forgotten, this is an equal sign and this would be less than or equal to or greater than or equal to. So anytime you have the greater than or less than symbol, that's an inequality, which means you're setting up a system that is not equal. I'm sorry, not a system. You're setting up things that are not equal. Now the good news is you already know how to do the inequalities, but we're going to start by taking a look at an equation to refresh your memory first. So here we have our equation. And we're going to use Don't Call Me After Midnight, which you should be familiar with. We don't have anything to distribute. We can combine like terms. If you look, we combine 2x and 3x to get 5x. Write down what we have, which is the 6, and that equals 71. So we combine like terms. We don't need to move the variable. We only have one. We do need to add or subtract, and I'm going to subtract 6 from both sides. We're left with, this cancels out, so we're left with 5x equals 65. I need to multiply or divide. The answer is yes, so I'm going to divide by 5. What I find out is that x equals 65 divided by 5. So my solution is x equals 13. If I want to check it algebraically, then I think back on this equation at the top that said 3x plus 2x plus 6 equals 71. So I'm looking back at this equation. And instead of an x, I substitute in 13. So it would be 3 times 13 plus 2 times 13 plus 6 plus 71. So you should notice that whereas there is an x, I've written a 13 instead. When you plug that in your calculator, meaning you plug this in your calculator, you get 71 equals 71. That's a true statement, which means our answer checks, which means we have the correct solution to that equation. If I wanted to represent that on the number line, then I would show 0. Sorry. Let me do this right. Then I would show 0. And if x equals 13, then let's see. If I do it by 2, 4, 6, 8, 10, 12, 14, then that means my solution is right here. You'll notice that if it is an equation, the solution is 1 point. Now let's go take a look at that same problem, only this time let's change it. Instead of an equal sign right here, we're going to do an inequality. And I wonder what's going to happen. So we're still going to use Don't Call Me After Midnight. I'm going to use blue on this one. Don't call me after midnight. No distribution. I do have combined like terms. So I know that these are the same because they both have an x at the end. So I have, not 3x, my apologies. So I'm going to say 5x plus 6 is less than or equal to 71. I don't have to move the variable. I do need to add or subtract. So I'm going to subtract 6 from both sides. Again, the steps are the same. 5x is less than or equal to 65. Divide by 5. And my solution is x is less than or equal to 13. Okay? Now these are different. If you look here, this says x equals 13. That's one number. Whereas here, this is any value, any x value less than or equal to 13. Okay? That means I can pick any number less than or equal to check my answer. So if I want to check it, I'm asking myself, what number is less than 13? Now I'll tell you, I'm going to stay away from negatives for the obvious reason. But I'm going to choose something that's easy. So I'm going to choose 10. To me, multiplying by 10 is easy. And everywhere there's an x, I'm going to put a 10 in this time. Remember, we're using that same equation from the beginning. Right? That same equation that's up here. And I put in the 10 and I get 30 plus 20 plus 6 is less than or equal to 71. Do that in my calculator and I get 56 is less than or equal to 71. Is 56 less than or equal to 71? The answer is yes. So I do have the correct solution to this inequality. That means my answer is correct. Now if I want to represent that on a number line, let's see, 0, 2, 4, 6, 8, 10, 12, 14. So 13 is going to be here. Because it has the line underneath it, because it has the equal sign, right? This is less than or equal to. That's what that line means. Then I'm going to use a filled in or solid circle. And I'm going to shade in the direction where numbers are less. Okay, so I ask you, is 14 bigger or smaller than 13? You should be saying bigger. And then is 12 bigger or smaller? It's smaller. So I'm going to shade in this direction. Now when you shade, make sure you give us a good solid line so we know that you know what you're doing. Okay? So that means any number that falls in this shaded area, included these negative numbers over here, we will have a solution. So with an inequality, you have infinite number solutions in this case. However, with an equation, you only have one. So when you think through this, what are some similarities between equations and inequalities? I want you to jot down some ideas real quick. Pause the video and jot them down. What is the same between equations? What's the same between equations and inequalities? Jot them down and then start the video again. So one of the things that's the same is you solve, oh wait, you guys can't read cursive. Sorry. You solve using don't call me after midnight. Or you could say you solve them the same way. Is there anything else that's the same? Okay, the solution can be graphed on a number line. However, does it look the same when we graph them? No. If it's an equation, it's 1 point. If it's an inequality, it's infinite points. We've got a shaded area that counts as our solution. All right, now let's go look at this whole concept of inequalities and equations. Okay, so we're going to switch to the back of the notes. Again, the whole thing we're doing is we're working the same problem, only one time you're seeing it as an equation. So here you're seeing it as an equation. You know it's an equation because it has an equal sign. But here you're seeing it as an inequality, and you know it's an inequality because of the greater than sign. Okay? So let's walk through the steps. I'm going to zoom in on the equation, and I'm going to go all the way through the equation. All right. So we're going to use don't call me after midnight. Anytime we're solving an equation, we're going to do that. First thing we need to do is distribute. So I say 1/2 times 4. That gives me negative 2x. Negative 1/2 times positive 2 gives me negative 1. And then I just write down what's left over here on this side. Can I combine like term? The answer is no. Can I move a variable? Yes, I can move this negative 4x. Now I'm going to choose to move the negative 4x because it's negative and I want to keep it positive. So I'm going to add, and I'm left with 2x minus 1 equals 11. Do I need to add or subtract? The answer is yes. I'm trying to get the variable by itself, so I'm going to add 1 to both sides. These cancel out, and I'm left with 2x equals 12 because 11 plus 1 is 12. I need to get x by itself, so I'm dividing by 2. Those divide out to give me 1, which means x equals 6. That's my solution. Now I'm going to check it algebraically. That means I'm going to use that same equation from up here, and everywhere there's an x, I'm going to put in 6. So I'm going to write 6 right here and a 6 right here. Now, I can take this part and put it in my calculator and this part and put it in my calculator and see if I get the same answer. So if I take the left side and I put it in my calculator, I get out negative 13. When I do the same thing with the right side, I get negative 13. Do these match? The answer is yes, which means I get negative 13 equals negative 13. So that means I have the correct solution and I can move forward. Now our solution is not negative 13. Our solution is 6. The fact that we have negative 13 equaling negative 13 tells me that I have a true statement. So I have 0, 1, 2, 3, 4, 5, 6. I could have put that in a different place. Doesn't really matter as long as you label it and draw your point. So this is my solution. Notice I have an equation and I have 1 point. Now let's take a look over here and see what happens when we change it to an inequality. All right, so I'm still using Don't Call Me After Midnight. I'm going to take negative 1/2 and multiply it by 4x. I get negative 2x. Take negative 1/2 and multiply it by 2. And I get minus 1 greater than 11 minus 4x. So I've distributed. I can't combine. I can move the variable, and I'm going to add 4x to both sides. I have 2x minus 1 is greater than 11. Can add or subtract, so I'm going to add 1 to both sides. And I have 2x is greater than 12. I'm still trying to isolate this x, which means I need to get rid of this 2. So I'm going to divide both sides by 2, and x is greater than 6. So our solution is x is greater than 6. That means any number bigger than 6 will give us a true statement and be our solution. Now in this case, I want to graph this one and then go back and look at this part. So if it's greater than, so I'm doing any number greater than 6. So this is a greater than. It does not have the line underneath it, which means I have to do an open circle. That means it cannot equal 6. It can equal everything up to 6, but it can't equal 6. And it said x is greater than 6. So my question to you is 0 greater than 6? Is 0 greater than 6? Yes or no? You're right, it's not. So then I'm going to look at this one. Is 9 greater than 6? The answer is yes. So I know that I'm going to shade towards the 9. Oh, that is not a very good arrow, but you're just going to have to pretend it is. Okay, that's really ugly actually. Okay, so when I look at this, I see that 7 is a solution, 7.5, 8, 8.1, 8.2, 8.3, anything that's bigger than 6 counts as a solution. So when I go here to check it algebraically, I ask myself, what number is greater than 6? Well, I'm going to choose 10 because it's easy to multiply. I'm going to put this side in my calculator first. So 40 plus 2 is 42 times negative 1/2. What do I get? I don't have a calculator on me. That's unfortunate. I'll have to do some math. Hold on. All right. So 11 minus 40. So if I say 11 minus 40, then, oh, how quickly my brain is fried. 929. So then it's negative 29. And And then this is going to be 42. That's going to be 21. So it's going to be negative 21. I just did that real quick in my head. If you can't, that's okay. Choose a different number, do your calculator. So what we're asking ourselves is negative 21 greater than negative 29. Well, you'll remember when it comes to negative numbers that the closer it is to 0, the bigger it is. And this is further away from 0, right? So here's 0. Here's negative 21. Here's negative 29. So negative 21 is bigger than negative 29. So this is a true statement. So we've solved it correctly. Now, what are the similarities and the differences between these? Now, we did similarities just a minute ago. So I want you to deal with what are the differences between equations and inequalities. I want you to pause the video and jot down some ideas and then come back and watch the video and see if I get them all. So when I think of differences, to me it seems obvious. One has an equal sign and the other has a greater than, less than, a greater than, less than or equal to, or greater than or equal to. To me that seems easy. If it's an equation, then one solution. Whereas inequalities have shaded areas, and I'm going to use this simple, which means infinite solutions, right? Remember when we were talking up here, I said it could be 7, 7.5, 8, 8.1, 8.2, 8.3, 8.4. It could be 7.11, 7.12, 7.13, 7.14, and I can go even smaller, 7.1111, 7.112, and I can do that over and over again. So it has infinite many solutions. I think that's all I've got for differences for right now. All right. So I want to make sure before you go into the homework that I catch you up on a couple of things. All right. So we have less than, and we have less than or equal to, and we have greater than, and we have greater than or equal to. Now, if you have a hard time remembering that this is less than, then just think of it as a loser. I remember it with an L. If I can bend it back and make it into an L shape, then it's a loser. So it's an L. So it's less than. All right? So this is less than. If it has a line underneath it, then that means it's less than or equal to, which means I use a solid circle when I'm graphing. Whereas this one would also be a solid circle because of the line that's underneath it. These do not have lines, so it's going to be an open circle that I would graph. And we talked about that on this problem right here. This one right here, okay? Now, for some reason, the homework slide didn't pull in, so I'm going to take a minute to just kind of explain the homework slide. When you look at your homework, it follows the concept of the notes. This problem here and this problem here are the same. What's different is this has an equal sign and this has an inequality, okay? And so what we're having you do is exactly what we did on the notes. We want you to do all those steps for an equation and then all of those same steps for an inequality. Remember, what we're trying to get, that's kind of cool, it kind of looks like a face. What we're trying to get is with glasses. How's that? What we're trying to do is we're trying to get you to understand the difference between an equation and an inequality. An equation has a solution that's 1 point, and an inequality is going to be infinite number of solutions, and it's a shaded area. There's no one right answer, okay? So good luck on that homework. If you have any questions, feel free to get tutoring with us, and we'll talk to you soon.